algebra students. In this video, we're going to start talking about graphs. We have two videos for this lesson about graphs, and then coming up, we're going to have problems about graphs in pretty much every problem set. And these problems take some time and thinking, because we're not just going to be simply browsing past these graphs. We actually have to do what it says in the title: analyze and compare and draw conclusions based on graphs. Now in this lesson, this first video, I'm going to share with you the different types of graphs, and we're just going to look at one type in this video. In the next video, we're going to do the lesson practice, where we're going to actually see all of the different types of graphs you're going to be expected to work with. Let's get started. The first type of graph we're going to mention is a bar graph. It's a graph that uses vertical or horizontal bars to compare data. We can also consider a double bar graph, where we put two sets of bars side by side to compare two different sets of data that are related to each other. For example, it might be sales in 2022 and sales in 2023. You can compare how you're doing this year compared to last year. Let's take a look at a exploration involving bar graphs. So here's a sample survey that was asked students to name their favorite type of pet. The results are shown in the bar graph. What information is shown on the vertical axis of the bar graph? Well, the vertical axis here shows the type of pets, okay? Sometimes we will have categories on our axis. It's called categorical data, where, fish is not a number. Hamster is not a number. These aren't numbers along this axis of the graph. They're just categories. And what do we do along the other axis, the horizontal axis? We count how many members there are in each category. How many fish? How many hamsters? And actually, remember, these are students who said fish were their favorite pet, or hamster were their favorite pet. All right, we need to use the graph to complete the table. So let's do that. So now keep in mind, when we're reading a graph, if I don't have the raw data in front of me, sometimes it's kind of hard to tell exactly what number each of these bars corresponds to. But if I had to guess, I would guess that the number of students who said dog, that's this bottom one, let's see, we're counting up by 50s on the lines. So it's not quite a fifth. I would say it's like probably around 158. That's my best guess. The number of students who say cat, well, it's not quite 150, and it's pretty much below 150, the same amount that dog was over. So I would guess 142. Bird, ooh, that one's under 50, about the same amount. It looks like it's a little more than 4/5 of the way there. So I'm just gonna say that it looks pretty close to the same. That's gonna be about 42. Hamsters, if I look at that one, let's see, that might be a full 2/5 over. So I'm gonna say that hamsters is, let's see, that would be 70 out of, because it's past 50, it's not even close to 100. I would say 70. And then fish, same deal there. It looks like it's going to be about the same amount under. So I would estimate that to be about 92. Okay, now, it's a little silly, I guess, for me to end all of these in twos. I'm just noticing that this gap here is about the same as this gap here, is about the same as this gap here, is about the same as this overage here. Maybe that is a full fifth of the way. It just doesn't look like it's a full fifth of the way to me to count, make it so that there were 10 fewer. So this would be 90, and this would be 40. But maybe you see it a little different than me. Remember, when we measure, I've talked about this in science class, I talk about measurements. When we measure, that last digit is really up to the measurer's interpretation. All right, so the question is, how many students were surveyed? Now, it doesn't tell me up here how many students were surveyed, so what do I have to do? I have to add together all of these students. So let's see, if I add these together, 142 plus 158 is going to be 200, 370. This is going to be 412. Plus 90 will be 502, plus my last 2 is 504. So when I add all my numbers together, this adds up to 504. Now here's the thing about that number. I will bet they were trying to go for 500 students surveyed. But when I add all my numbers, I get 504, so that's what I have to leave it at. And then finally, Which pet did students choose twice as often as the hamster? Well, hamsters were here at about maybe 70, right? So which was twice as often? It was the cat was probably about twice as often at around 140, somewhere kind of close to 140. Explain? Well, I would explain by saying the bar is about twice as long. Let's see if I can stretch this out here, and then we'll finish that out. The bar for cat was about twice as long. Okay, that's how we use bar graphs and how we interpret from them. Let's continue. There's 3 other types of plots I'm going to mention, or graphs, and we're not going to do anything with these right now. We're going to actually work with these when we do the lesson practice. A stem and leaf plot. That one is the most complicated one to make, but also one that will keep coming up again and again and again and again. It's a data display that uses higher place value digits as stems, as stems, and lower place value digits as leaves. You'll see what that means. That doesn't make a whole lot of sense right now, but you'll see what that means. A stem and leaf plot is great for counting how spread out your data are across different place values. You'll see what I mean by that in just a moment. Line graphs and double line graphs are very similar to bar graphs, except they show a continuous change in data along a line over time. A double line graph is like a double bar graph. We just put 2 lines next to each other. We'll see those in just a moment. And then finally, a circle graph is more commonly known as my favorite kind of graph, the most delicious type of graph, a pie chart. Hey, did you realize that a pizza is actually a real-time pie chart of how much pizza is left? A circle graph uses sections of a circle to compare parts of the circle to the whole. So a circle graph is used when we just have one set of data and we want to see what percentages of that data lie in different groups. We'll see that in just a moment too. All right, now that I've introduced the types of graphs, the only way we're going to learn about this is by getting hands-on. Let's continue on to the next video where we create a stem and leaf plot and we view examples of bar graphs, line graphs, and circle graphs. Let's keep going.